Hey guys, welcome to Math 243, Chapter 1 lesson. So, I'm going to be doing Chapter 1, 2, and probably 3, all for PowerPoint for sure. After that, I may use some PowerPoints. I may do some kind of chalkboard in my at-home office. And so we'll see kind of how those go. For Chapter 1, for sure, there will be no example videos. It's all pretty much just terminology and getting used to these ideas and concepts that are used in statistics. You can find a copy of these slides linked in my Open Math, so make sure you go there and get those if you need them. I'm going to go kind of not quickly, but faster than what most people can write down normally, since this is a video and you can pause things. So, Chapter 1, this section is an overview. Okay, so it talks about the process involved in conducting a statistical study. There's really 3 main components. There's the preparation, the analyzing of the data, and the conclusions. Okay, so we're going to talk about how to prepare, analyze, and conclude a statistical study. Now, this is just an overview of these things. This is kind of a preview of what we're going to be talking about throughout the term. Okay, so how to prepare. So when we're preparing for a study, we need to ask ourselves a couple things. What does the data mean, and what's the goal of the study? Okay, so what does the data mean? What's the intent of the data? What is it that we're trying to collect? Those sorts of things like that. And the goal of the study, is it just a purely, curiosity type study? You're just trying to figure something out. Are you trying to prove a point, right? Or is it something like a company trying to approve a drug? Is it something like the tobacco industry trying to show that cigarettes are not harmful? Is it anti-tobacco showing that cigarettes are harmful? What's the goal of that study? Okay. When we're looking at this can kind of help us with the source of the data. Now, sometimes we may be the source of the data. We may go out and collect the data in the world, in which case our source is ourselves and the actual collection process we create, which we'll talk about later today. But if it's data that we are gathering off of, say, a website or something like that, is the source objective or biased, right? So example, that tobacco industry job or study that I was kind of mentioning just a second ago, right? That may not be a very objective study, right? They may be looking for people to show that tobacco is not harmful or whatever their view and their goal is. Okay, so we need to make sure we're watching out for biased sources. Okay, we've already talked about a couple examples. See if you can think of another example yourself. The sampling method. This is a really important thing. How is the data collected? How is that sample created? Okay. If that sample is not a good sample, do you think that affects the quality and the validity of any conclusions made from that data? I definitely say it would, right? If we want to say, figure out how many % of shoppers buy exclusively online, and to figure that out, we are polling people in front of Walmart, right? Not a good study, right? Because those people are most likely going to be biased to buying things in store since they're going to a store. Another form of kind of sampling method issues are voluntary response or self-selected samples. Okay, these are typically biased samples because self-selected, what that means is it's things like calling into a radio show, emailing back responses, things like that, where the people choose to participate in that study. They're more likely to have some sort of a vested interest in the results of that study, or they have a strong opinion one way or the other. And so you don't get a real nice broad kind of sample. Okay. Now, analyzing the data. It's gonna be really quick. Later chapters are gonna discuss how to do this. Now, for those of you who are computationally nervous in this class, maybe in 111 you were kind of struggling with some of the methods of solving problems, things like that, and you're kind of worried this is gonna be a really big, heavy mathy course, right? Stats is typically a lighter on the kind of computational math side, the actual like, here's a formula, plug things in and go. And it's more so about the interpretation of the mathematics. And so what's really nice is with our, even just our calculators, but also things like Excel and different sort of web-based and computer-based programs, it really takes the computational skills out of this course. It's really just a matter of using common sense and paying attention to the sound statistical methods. So, how do we conclude these things, right? Statistical significance. That's something that you're going to hear in statistical studies forever. As you go through college and you're reading studies and things like that, or you're performing them, things mean statistically significant. Now, all this means is that there was a result that was very unlikely to occur by random chance, right? So imagine if we roll a standard six-sided dice, right? We roll it 10 times, okay? Or yeah, let's say 10 times. And one time we get 5 5s, okay? Now, that may be significant to maybe saying that that isn't a fair dice. Maybe it's weighted so that 5s come up more often. Or maybe it's just random chance. That's something that we're going to look into later in this term on how to figure that out. But that's what a statistical significant result means, is that that result was unlikely to occur just by random chance happening. Now, what's the difference between statistically significant and practically significant, or the practical implications? Okay, it really just comes down to common sense. I'm going to give you a little example here. Okay, this is a real test, real survey, real thing that was done. So they tested Atkins weight loss programs, 40 different people. They had a mean or average weight loss of 4.6 pounds after 1 year. So using statistical methods that we'll be discussing later in the term, they concluded that this is statistically significant, okay? What that means is that the random chance of 40 people having an average weight loss of 4.6 pounds after 1 year is very unlikely, okay? So just grabbing 40 people on no diet whatsoever, just doing their own normal thing, the chance that that group will have an average weight loss of 4.6 pounds is very small. So that means this is a statistically significant result. However, it's not practically significant. If you tell me, join up my diet program, in 1 year, you're going to lose 4.6 pounds, that isn't very good, right? So while it is statistically significant, and say a commercial could say that over the course of a year, there was a significant, or the weight loss was significant, right? What they mean is statistically, they're bending words to market things. So we got to be kind of cautious and be paying attention to that when we're looking at different conclusions and studies, as well as making conclusions ourselves. Now, some more potential pitfalls. Causation. This is a huge issue in statistics. Okay, concluding that one variable causes the other variable, when in fact they're just related. Okay, later in the term, towards the end of the term, we'll do a little bit of a unit on causation, and we'll talk about how to assess causation versus correlation. And there's a really fun example I have that shows the pounds of lemons imported from Mexico has a correlation with the number of fatal car crashes in the US. The more pounds of lemons imported from Mexico, the more car crashes in the US. Now, that doesn't mean that importing lemons from Mexico causes more car crashes in America or in the US, but there's a correlation there, okay? And so that's kind of an issue that we want to be very careful of when we're wording our result and our conclusions, is to be careful using the word cause and not correlated, okay? Those two things are very different, all right? Another issue is small samples, okay? The idea of statistics is to use samples to infer things about the population, okay? It's very unrealistic to go through and poll the entirety of the US, but we can do a sample, right? And then we can use that in some statistical methods to infer data about the rest of the population. Now, it's very dangerous to do that based off of only 3 students. Now, if our population is small, let's say this class has 35 registered students. If I did a sample of 7 or 8 students, that's a pretty good chunk of the class, statistically speaking. But let's say we're talking about students at Chemeketa. If I did 7 or 8 students, that's barely anything. That doesn't really tell us anything. So we need to make sure that we're careful with the size of our samples and getting an appropriate size. And that's, again, something later in the term we're going to talk about how to determine a necessary sample size. Loaded questions. This is a really tricky one because it's really hard to make a question completely unloaded. It's always going to carry some level of loadedness into it. And you'll see on the next slide kind of where that comes from. So the wording can be really kind of interesting, right? Should the president have line item veto to eliminate waste, right? That sounds like great. Yeah, you should be able to eliminate waste, right? Should the president have a line item veto or not, right? That is not adding that eliminate waste idea, right? And so that eliminate waste is a kind of loading of the question. They did a study where they asked the same question, just reversing the order of the two things, and got different results. So the question initially was, would you say traffic contributes more or less to air pollution than industry? They got traffic was more than industry. Then when they reversed them, would you say industry contributes more or less to air pollution than traffic? They got the reversed results. Okay. So how could you reword this so that it is less loaded, so there's less of an issue? I'll give you a second to think about it. Okay, it's been a second. So an easier way to reword this is to not put so many words, essentially, between your options. So would you say traffic or industry contributes more to air pollution? Or would you say which of these two options contributes more or less to air pollution, traffic or industry? So by choosing to put your options further apart will significantly influence the sample and their ability to kind of independently and unbiasedly choose the results. Terminology. Now this is so big. The entirety of this term is going to depend on your ability to differentiate these terms, okay, to understand these definitions. So it's really easy when we're looking at a PowerPoint and I give you the printout of the PowerPoint to just be like, yeah, cool, I've got the PowerPoint, I'm good. I cannot emphasize enough how important it is that you know these terms forwards, backwards, inside out, left, right, every which way you possibly can, so that you know exactly how to use them and exactly when to use them, okay? So, as I said already, the subject of statistics is about using sample data to make inferences about an entire population, okay? So a population is the entire group of whatever broad or narrow that subject is. A sample is simply any subset of that population, okay? If we, again, chose like the 35 students in this class that are registered, if I looked at 34 of them, that would be considered a sample. Even though I'm really basically at the population, I'm just missing one because I'm not looking at everyone. It's a sample, not the population, okay? With that said, here's two terms that are going to be something that you really need to remember. And they're really easy if you remember a simple trick of letter association. Parameter. A parameter is a numerical measurement describing some characteristic of a population. These characteristics could be things that we think of as physical characteristics. They could just be a mathematical characteristic, averages, weights, colors, all sorts of different things, okay? Notice population, parameter. Those two things go together, population, parameter. The next is statistic. A statistic is a numerical measurement describing some characteristic of a sample. Statistic, sample, SS, population parameter, PP, okay? This class is all about statistics, right? We're not taking Math 243 parameters, right? We're taking statistics. because it's the idea of collecting data about a sample and making inferences to the population. So that's why we're looking at statistics. But it is very important to be able to recognize whether we're dealing with a sample or a population, whether we're dealing with a parameter or a statistic. Now, when we're collecting data, there's two general types of data. There's quantitative and qualitative. Quantitative is a numerical type of data. It consists of numbers, typically representing counts or some sort of a measurement. Okay. Within quantitative data, there's two types. There are discrete data. So this is typically done with counting. Okay. And it usually takes on values of, say, like 0, 1, 2, 3, 4, so on, so forth, right? Our example, number of eggs a hen lays. The other is continuous data. Okay. This has infinitely many possible values that correspond to some continuous scale, right? That's a big idea, continuous scale. There's no gaps or jumps between values, right? So we can think of the gallons per day that a cow produces as our example here. Now, we can actually tweak data to either be continuous or discrete based on rounding. So if we look at this example here, the example within the example, right? Cow produced 2.34315 gallons per day. We could take that value, that's its continuous value, that's a exact value. Notice how it has all those decimals, right? It's got any value between anywhere, okay? But if I said the amount of cow produces in a day rounded to the nearest gallon, that changes this from continuous data to discrete. Because if I say rounded to the nearest gallon, either they produce 1 gallon a day, 2 gallons a day, 3 gallons a day, 4 gallons a day, and so forth. Even though that data here, when we just say the amount of milk that a cow produces, that amount is continuous. There's no kind of chunks. It's not like a cow just plops out, 1 whole gallon at a time, right? It's a continuous amount. So there's that. The next type of data is categorical, or I like to say qualitative. Okay, and this is typically a kind of name or label type data, right? Genders, colors, right? Say if you take a poll to see what color shirt people are wearing, right? That is a type of categorical qualitative data. Okay. How to collect data, collecting the data, right? So there's two types of studies that we'll do when we're creating a sample. There's an observational study and an experimental study, okay? They're really simple. An observational study simply measures some characteristic without attempting to modify the subject being studied. So if I go and look up every student in this class's, say I look up your GPA, that's an observational study. I'm simply observing what your GPA is. I'm not doing anything to modify or to affect your GPA. However, an experimental study is to apply some sort of a treatment and then observe its effects. So let's say I made all of you guys take a term of tutoring and then looked at your GPA, right? I applied some sort of a treatment, that tutoring, and then I observed its effects, okay? For the most part, what we're gonna be dealing with a lot of the time is observational studies. They're just a little more kind of straightforward in this class, but experimentals just work just as fine too. So here's an example of an observational study. You read through that. Here's an example of an experimental study. Read through that. Our methods of sampling. Okay, this is how are we collecting these samples. In an ideal, perfect world, which we obviously do not live in, we would use a simple random sample. Okay, so this is a sample of n subjects. So n is just a number, right? So it's the number of things that we are looking at, is selected in such a way that every possible sample of size n has the exact same chance of being chosen. Now this is a little bit different. We're going to talk about something called a random sample. Okay, so the difference here is that a simple random sample, every single possible sample of that size has a chance to be chosen. Okay, it has an equal chance to be chosen. We're going to talk about kind of later in the term, we'll talk about counting and probabilities of things happening and how it's different from, say, an individual item versus a group of items being chosen, how that varies. So there's 5 methods that are typically used, right? Our goal, our idea is to strive to get a simple random sample, jumping back a slide. Okay, and these are 5 ways that it can happen. Some of these are good, some of them are not so good, and we'll talk about each one kind of as we get through. So kind of our best approximation to a simple random sample is a random sample, okay? This is where members of the population are selected in such a way that every individual member has an equal chance of being selected. Notice the difference is here, it's every individual member has an equal chance versus a simple random sample is every possible group of a certain size has the same chance, okay? So those are kind of our differences. And it may seem kind of intuitively like those seem like the same things, but mathematically they're not. So the random sample is what we're mostly going for. And typically when we do something, we will kind of automatically assume in a random sample, or it'll be explicitly stated in problems as well. Systematic sampling. This is a very convenient way to do sampling. If we have something like, so for random sampling, like if we have some sort of a computer program that can randomly select, say, like student K numbers for Chemeketa, right? That could be a decent way to do random sampling, but it's really hard to truly do random sampling, especially if you're doing, say, something like a person out there taking a survey, you know. And so that systematic sampling is really effective for stuff like that. So this is where we choose some starting point, and then we choose every kth element in that population. So K is just this kind of random number. So in this example here, we're choosing every 3rd element. So we start from we grab the 3rd item, then the 6th, then the 9th, and so forth. This is something that's really useful in production lines and kind of assessing quality control, grabbing every, say, 50th item produced off of that line, checking it, and going from there. Convenience sampling. This is typically not a good method of sampling. It is really just finding the easiest sample to get. For me here, let's say I wanted to do a sample to see what people's favorite color is, and I just went out in my living room and asked my wife and 2 kids. One of them would drool on me, the other one would yell some random color that she found in her hand, and my wife would pick her favorite color. But that's neither here nor there. That would be a convenient sample. That wouldn't be a really effective sample to be able to talk about, say, all people in Salem. So convenient samplings have their uses, but most of the time they're not very good. Okay, now, real quick, I'm going to jump between some slides. So stratified sampling and cluster sampling. These are really kind of similar, but they're different in kind of a big way. And these two are really commonly used methods of sampling. So stratified sampling is when we take the entire population and we divide it into at least 2 different subgroups that all share some sort of a characteristic, right? A very common one is, as depicted here, is men, women, okay? You could also split it up into, say, age groups, right? We see that a lot of the time when we're looking at surveys, 18 to 24, 25 to 30, 31 to 35, whatever it is. So each group is called a stratum. And then what we do is we randomly select from each of those different subgroups. So if we split everyone into men and women, then we select an equal sample from each group, okay? That's how we get a stratified sampling, okay? Cluster sampling is when we divide the population into different sections or clusters. It's typically done geographically. A lot of the time this is done like using counties or other things like that. And then what we do there is we randomly select some clusters or some of those groups, and we sample all of the members in that group, okay? So the big difference between these two is that with stratified, okay, both stratified, and cluster sampling, we're splitting the population into groups, okay? Difference is that so make sure you are very clear on the difference between cluster and stratified sampling methods. Okay. Errors, types of errors. We're almost done. No matter how well and perfectly executed your plan and your sample is and your statistic and your analysis, you're a human. Humans are involved in the process. There's potential for errors. Okay. A sampling error is when there's a difference between the sample result and the true population. Okay, this can be from basic kind of random chance. You happen to get a weird group. Okay, it could be from choosing an incorrect or inappropriate sampling method, right? These are just kind of situations where you took a sample of everyone's age and you happen to, be doing that as a nursing home bus pulled up. And so your age is a little bit too old. A non-sampling error is when there is bad recording of data, using a bad method, okay, bad calculations, typos, things like that, okay? And then there's also a non-random sampling error. So this is just kind of using a bad sampling method, right? So sampling method kind of really plays into effect in all of these possible errors. So make sure that you are kind of being careful and cautious of how you're looking at these samples, what the method used was, and how we can go about from that. Okay, so that's the last slide. That's it for you guys. I hope you guys enjoyed that lecture. Pause as you need to write things down. Now, at this point in time, you should have already been filling out the lecture guide notes or the guided lecture notes. Make sure you guys are filling those out and understanding those, okay? That is not the exclusive list of all the notes you should take. Take more notes than that. Now, go do the video questions, get 100% on that, and you'll have access to chapter 1's homework problems. And that's it for this week. I highly recommend you guys getting on chapter 2 as soon as it becomes available. I will send an email out once that video is posted. Don't wait until next week. Work ahead as you can. All right, you guys. Thank you so much. Have a great day.